right, so we're going to get started on lesson 5.5 today. Let me present my screen. Okay, so we are going to look at how to add functions, subtract, multiply, and divide to operations on functions. Let f and g be any two functions. A new function can be defined by performing any of the four basic operations on f and g. All right, so you can see the example: f of x is given as 5x and g of x is given as x plus 2. So if we're adding the two functions, you add 5x plus x plus 2 and obtain 6x plus 2. So combining like terms. Subtracting functions, same thing. Don't forget to distribute that negative into the second set of parentheses if there are some. Multiplying two functions, in this case, we have to distribute the monomial to the binomial, and then dividing two functions. All right, we're also going to be talking about the domain and range. The domains of the sums, difference, and products and quotient functions consist of x values that are in the domains of both f and g. Additionally, the domain of the quotient does not include x values for which g of x is equal to 0. Since you can't divide by 0, you're going to have a restriction on the g of x. All right, the note that I just want you to consider here and think about here is we're going to think about domain of original, not of the new, but of the original. All right, and I'll explain that as we get into the problems. Okay, so with that, let's jump right into the problems. Just like lesson 5.4, I'm going to break this into a 2-day lesson. I'm going to work on the odds, and then we'll work on the evens in the next video lesson. All right, so today we'll work on the odds. So it says find f plus g of x, f minus g of x, state the domain of each, then evaluate f of g and f plus g and f minus g for the given value of x. Okay, so first we're going to do f plus g of x. Okay, so f plus g of x. So you're going to take the f of x function, f of x, and you're going to add to it the g of x function, g of x. All right, so the f of x function is negative 1/2 cube root of x, and the g of x function is 9/2 cube root of x. Since they are like radicals, same index, same radicand, you just add the coefficients. All right, so negative 1, negative 1/2 cube root of x plus 9/2 cube root of x. You're going to add their coefficients, negative 1 plus 9, to get an 8/2 cube root of x, which simplifies to 4 cube root of x. So for f plus g of x, you get 4 cube root of x. Now you're asked to evaluate when x is equal to 1,000. So you're going to substitute negative 1,000 in for the x value. Okay, so the cube root of negative 1,000, and then, forgot an extra 0, and then you'll multiply that by 4. So you have 4 times negative 10, because that's what the cube root of negative 1,000 is, and you're left with a negative 40. All right, last step here is give the domain for the function 4 cube root of x. So I'll go back up here to talk about the domain. So remember, for the domain, you're going to look at the originals. Think about q. You really need to look at the radical where the variable is. Okay, so cube root of x. Can you take the cube root of negatives, positives, and 0? Yes. Over here as well. Can you take the cube root of negatives, positives, and zeros? Yes. So your domain is all real numbers. There's no restriction. X can be any single value you want it to be. Okay, so that is that. So the answer here, what I'd be looking for is this here, the new function when adding the two functions together, the domain and the evaluation. Now we're going to do the same problem, subtract the two functions. So I have f minus g of x. So you're going to take the f of x function, which is negative 1/2 cube root of x, and you're going to subtract away the g of x function, 9/2 cube root of x. Again, they are like terms, so you work with their coefficients. Negative 1/2 minus 9, so that's going to be a negative 10/2 cube root of x, which I can then simplify. So f minus g of x is equal to negative 5 cube root of x. The domain doesn't change. The domain is still all real numbers. And then you have to evaluate f minus g of x, when x is 1,000, negative 1,000. So you have negative 5 cube root of negative 1,000. The cube root of negative 1,000 is negative 10. So negative 5 times negative 10 is a positive 50. All right. So again, this would be the answer, and then the evaluation of 50. All right, let's move on to number 3. So starting by adding the two functions together first. So f plus g of x. Take the f of x function, 4x cubed plus 12, and you add to it the g of x function, 2x squared minus 3x cubed plus 9. Combine like terms. So you have 4 minus 3 is a 1x cubed. Then you go to your square terms. There's only a 2x squared. Then your constants. 12 plus 9 is 21. All right. That is f plus g of x. For your domain here, look at the original. Any restrictions on what you can plug in for x in the f of x function? There are none. You can cube a positive, a negative, and a 0. And fractions and decimals, any number you can think of. In the g of x function, can you plug in positive, negative, zeros, decimals, fractions, any number for x here and there? Yes, because you can square any number, you can cube any number. So the domain is all real numbers. All right. Last thing, we have to evaluate when x is 2 this time. So f plus g of 2. So I have 2 cubed plus 2 times 2 squared plus 21. So 2 cubed is 8, plus 2 squared is 4 times 2 is 8, plus 21. So I have 16 plus 21, which will give me 37. Okay, same problem, but now we're subtracting the two functions. So I have f minus g of x. Now watch this and be careful. Write the f of x function first. 4x cubed plus 12 minus, put parentheses. I didn't care about the parentheses in the last problem because I was adding. It didn't change the sign of anything. But when you're subtracting the function, you have to change the signs of all the terms of the second function. So it's going to be 4x cubed plus 12 minus 2x squared plus 3x cubed minus 9. So combining like terms leaves me with f minus g of x as 4 plus 3 is going to give you 7x cubed, then minus 2x squared, then plus 3. And your domain here is still all real numbers. All right. And then you just have to evaluate when x is 2 for this function. So substituting a 2 in. So it's 7 times 2 cubed minus 2 times 2 squared plus 3. So you're going to have 7 times 2 cubed is 8 minus 2. Oop, I could have done the multiplication. Oh, well, I'll do the multiplication next step. 2 squared is 4 plus 3. All right, and that's going to give you an evaluation of 51. Okay, so that's 1 and 3. Let's look at number 5. So same idea here, but you're going to first multiply the two functions together, divide the two functions, state the domain, and then evaluate when x is the given value. Okay, so for number 5, actually, let me give myself some more room first. All right. And let's just scribble this one out now because we're not going to do this one today. And that way I can have more space. Okay. So first I have f times g of x. So f of x is negative x cubed. And g of x is 2, the cube root of x. All right. So since one is written in exponent form and one is radical, you may want to rewrite the one in a radical as exponent. So it's x to the 1/3. And then I have so many parentheses here. Let me just write this as negative x cubed times 2 times x to the 1/3. Okay, I guess kind of crazy with all the parentheses sometimes. So when you have the same base, the rules to add the exponents, okay? And negative times 2. So I can write that negative 2 out front. And then it's going to be x to the 3 plus 1/3. Okay, same base. And you're multiplying the rules to add the exponents. So it's negative 2x to the 3 and 1/2, or if you want to write that as a mixed number, it would be 10/3. All right, so that is your f times g of x function. All right, now for the domain here, go back to the original. Can you cube any number, positive, negative, 0? Yes. Can you take the cube root of any number, positive, negatives, and 0? Yes. So the domain is all reals. Okay. Last part of this problem is evaluating when x is equal to negative 64. So I have f of g of x equals negative 2, and then I have negative 64 raised to the 10/3. All right, you may want to rewrite it as the cube root of negative 64 and then raised to the 10th. All right, and then multiply by 2. And you'd obviously probably want to grab a calculator for this one because it is quite a large value. It is negative 2,097,152. And there's your evaluation. Okay, we're going to do the same problem, but dividing this time. All right, so we have f divided by g of x. So I take my f of x function, negative x cubed, my g of x function. Again, I'm going to rewrite it with x to the 1/3. So in this case, when you have the same base, your exponent rule is to subtract. So first, that's a negative 1 there. I'm going to rewrite this as negative 1/2 and then x to the 3 minus 1/3. Okay, so the negative 1, 2, I just wrote as negative 1/2 because that's what it is. And then same base, subtract exponents. All right, so I have negative 1/2 x. 3 minus 1/2 is 2 2/3, okay? Or change that into a improper fraction. So that's 6, 7, 8 thirds, okay? All right, so that is how you can leave it. If you want to put the x up in the numerator and put it over 2, you can, or just leave it like this. The domain. Now, your domain for this problem, if you go back to the originals, and we already said this in the last problem, you can cube any number, you can take the cube root of any number. When you're dividing, if the variable's in the denominator, there may be an additional restriction you need to consider. In this case, the variable's not in the denominator, so it's still all real numbers. All right. And then let's see what I have to do next. Oh, so then I have to evaluate when x is equal to negative 64. So negative 1/2 and then negative 64 raised to the 8/3. Okay, again, you probably want a calculator for this one. You're going to take the cube root of negative 64 and then raise it to the 8th and then multiply it by negative 1/2. It's kind of a larger number. It's negative 32,768. Okay. All right. Oh, you know what? I just realized I'm not correct about the domain. Oh, darn. Hold on. Hold on. Didn't mean to hit that. So I'm sorry. We have to go back a second. I was just realizing. So negative 1/2 x to the 8/3. When you're dividing, I said the domain was all reals, and I'm just realizing that's not correct. Almost correct, but not quite correct. And then I had f of g of negative 64. That was negative 32,768. Sorry, let's talk about the domain for 1 second. So I am correct. You have to look back at f of x, g of x, and then the original, but you actually have to look one more spot. So again, you can plug any number in for x and take the cube root. You can plug any number in for x here and take the cube root. So that's good. And then yes, x is in the numerator, but actually what I meant to check and I didn't, and I have to rewrite this part. At the very beginning of the problem, I had negative x to the third over 2x to the 1/3. This is actually where you also need to check. Remember what I said, the denominator cannot be 0. So if you plugged a 0 in for the x here, the denominator would be a 0 and the function would not work. So you actually have to look at how the problem is originally set up, that first step. And I'll do this again in the next problem since I mess this part up for a second. But x cannot equal 0. So it's all real numbers except x cannot equal 0. Because if x is equal to 0, the denominator will be equal to 0. So all real numbers except x cannot equal 0. Okay? All right, so I'll re-explain that again in the next problem as well. Let's go down to problem 7. One more time to practice this. So again, I'm first going to take f times g of x. So I have 0.25x to the 1/3 times negative 4x to the 3/2. All right, so you can rewrite this in any order. So I'm going to rewrite 0.25 as 1/4, just makes the math a little easier for me. So 1/4 times negative 4 times x to the 1/3 times x to the 3/2. That's the exact same thing, just I turned this into a fraction and I put the negative 1/4 and the negative 4 next to each other because they're going to be multiplied together. And then the variables, because they have the same base, and I'm multiplying the rules to add my exponents. So it just makes it a little bit easier to look at. All right, so 1/4 times negative 4 is negative 1. And then times x to the, you're going to add the exponents together. All right, you would need a common denominator here. Your common denominator would be a 6. So if you're making this a 6, it would be 2 6s, right? That simplifies down to 1/3. And then multiply top and bottom here by 3 to get 9/6. Okay, so then that is going to be, I guess I don't need to write the negative 1 anymore. That's going to be negative x to the 11/6. All right. So that's your function. F times g of x equals. Now let's talk about the domain. For the multiplication one, you just have to look back at the original f of x and g of x. You can take the cube root of any number. All right. So no restriction there. Here, however, you are going to be taking the square root, right? Because x to the 3/2 is the same thing as the square root. And the smallest number it can be would be a 0. You can't have negatives on the square root. So there is a restriction. X has to be greater than or equal to 0 because x can't be a negative. You can't take the square root of a negative number. All right. So at least not in the real number system. So it's all reals except, or no, actually it's x is not all reals. It's x has to be greater than or equal to 0. Because if you write all reals except x can't equal 0, that means it can be a negative, but it can't. So x has to be greater than or equal to 0. Okay. Last part for this problem is evaluating when x is a 1. So f of g of 1 is equal to negative 1 raised to the 11/6, which is just a negative 1. Okay. All right, now we're going to do the same problem, but the division. So it's f divided by g of x. So you take the f of x function, which again, I'm going to write it as 1/4 x to the 1/3 divided by -4 x to the 3/2. Now we can actually talk about the domain here, but we'll wait. We'll talk about it at the end like we normally do. All right. So we're going to simplify this. Okay. So when you have the same base and you have exponents, the exponent rule is to subtract. Okay. So you have negative 1/4 divided by -4. That's the same thing, not -1/4, excuse me, 1/4 divided by -4. That's the same thing as 1/4 divided by -4, which is the same thing as 1/4 times the reciprocal. The reciprocal is going to be -1/4. So this part of it, the 1/4 divided by -4, simplifies to a -1/16. Okay, so I did all that work to the side just to simplify that part of it. Now the variables, remember what I said, the rule is to subtract the exponents. Just like in the last problem, you want to get common denominators, and maybe I'll do the work off to the side over here. So 1/3 minus 3/2, looking at the exponents. If I want a denominator of 6, multiply top and bottom by 2 here, multiply top and bottom by 3 here. Okay, so it's 2 minus 9. So that's going to be a -7/6. Okay, so it's -1/16 x raised to -7/6. All right, so we can't leave it like that because the x is negative. So actually, let's first put the variable up in the numerator so you know where to move it to make the exponent positive, right? So if your exponent's negative, it needs to move to the denominator. So it becomes -1 in the numerator over 16x to the positive 7/6. That is your f divided by g of x function. All right, now your domain. All right, so remember what we said over here. You said that, or we said in the previous problem, that x has to be greater than or equal to 0, because 0 is the smallest number you can take the square root of. Here, it can be anything, but since over here, it has to be greater than or equal to 0. That's our restriction so far. But look back at this setup here, or even in this case, you can look at the final. Your denominator cannot be a 0. So if x is equal to 0 here, right? If I do 0 raised to 3/2, that's just going to be a 0. And then 0 times -4 is a 0. You can't have 0 as the denominator. So even though up here I said x has to be greater than or equal to 0, x cannot be equal to 0, because then that will give you a denominator of 0. So your domain is that x has to be greater than 0. All right. The last step of this problem is to evaluate when x is equal to 1. So I have -1/16 times 1 raised to 7/6. 1 raised to 7/6 is just 1, and then 1 times 16 is just 16, so it's -1/16. -1/16. All right. And let me see, what are we doing on the next page? That is it for this lesson. Yep, that's going to be it for this lesson. So like I said, this is a 2-day lesson. We're going to work on the even problems for day 2, just so that you guys hopefully get a good understanding of all the lesson, of all this stuff in this lesson and practice. All right, I'll see you next time. Bye.